So now let's take these derivative rules that we've learned or that we've proven and derived in the first couple of videos of this topic, and let's actually use them to take the derivative of a polynomial. So I'm going to consider the function f of x equals 3x to the fourth plus 7x squared minus 8x plus 5, and I want to find f prime of x. And in fact, this was the function I left you off with in 2.5 when we knew just the power rule. I said, hey, what about this function? What do we need to learn? And we listed off the things that we've learned in this video. So let's take f prime of x. And for this video, I'm going to use the rules that we got in this video rigorously. And then after this video, you're going to kind of have permission to do it much quicker. You're not going to have to go through these rigorous rules that we're going to do. So what I want to do is I want to take the derivative, f prime of x is the derivative of this whole function right here. So I want to take the derivative of this polynomial 3x to the fourth plus 7x squared minus 8x plus 5. Well, the first thing that I can do, the first rule that I'm going to invoke is I'm going to invoke our sum and difference rule. And I'm going to take the derivative of this polynomial. The sum and difference rule says I can take the derivative of each individual piece. So I'm going to make sure that the notation's there so that you can understand what's going on. But this is the derivative with respect to x of 3x to the fourth plus the derivative with respect to x of 7x squared minus the derivative with respect to x of 8x, and then plus the derivative with respect to x of 5. And so that's what we have right now. That's why the sum and difference rule is so nice, is because it allows me to take a polynomial and focus on each individual piece. So now let's talk about the derivative of 3x to the fourth. The constant multiple rule said that this 3 can actually be multiplied by the derivative, or it can come outside of the derivative notation if we want to think of it that way. So I can write that as 3 times the derivative with respect to x of x to the fourth. I can do the same thing with 7 right here. So I can say plus 7 times the derivative with respect to x of x squared minus, I can pull the 8 out, so minus 8 times the derivative with respect to x of x. And you'll notice what I've boiled it down to is I've gotten them down to the power functions that we were talking about in topic 2.5. Now the derivative of 5, this is why we learned the constant rule. The derivative of 5, the derivative of any constant, is just simply 0. And so it actually will not survive this derivative process when it's all said and done. So now let's use our power rule from topic 2.5. The derivative of x to the fourth is 4x cubed plus 7. The derivative of x squared is 2x to the 1 power, or just 2x. And then minus 8 times the derivative of x, which is just simply 1. And then the plus 0. And so what f prime of x equals, when I'm done here, 3 times 4, that's 12x cubed plus 14x minus 8. There's the derivative with respect to x. Now then, the expectation moving forward is going to be that you're going to be able to go from here to here in one single step, that you're not going to have to show this rigorous expansion of all the derivative rules we applied today. So let's take a look and see if we can't go from here to here in one single step. If I have 3x to the fourth, if I apply the power rule and understanding what's going to happen to this 3, I get 4 times 3, which is 12, and then reduce the power by 1, it becomes x cubed. For 7x squared, 2 times 7 is 14, and then I reduce the power by 1, so I got 14x. The derivative of a linear piece right here, this minus 8x, it comes out to be minus 8 because the derivative of x is simply 1, and then the derivative of the constant is always going to be 0. It's not going to make it into the derivative if it's a constant value. And so one of the things, just kind of clean up what can sometimes be a common mistake, make sure you understand the derivative of a linear piece like this ends up being a constant value. You actually do get a derivative of minus 8x. It's the minus 8 right here. The derivative of the constant, though, is in fact 0, so it will not make the process. It's a real common mistake to want to leave the x with 8x here. Don't do that because the power rule knocked it down to x to the 0. And then it's also a real common thing to leave the plus 5 because you're not sure what to do with it. The derivative of that constant value was 0. So in the future, you will be able to go from here to here in a single step. Just make sure you understood that this was really what was allowing you to do that.